Hi guys, today we're going to take a look at actually not just graphing lines, but analyzing those graphs in terms of two terms we've heard before, range and domain. So we'll start with defining the difference between an increasing function and a decreasing function. An increasing function goes up as you move from left to right, and a decreasing function goes down as you move from left to right. So one thing you can do is analyze a graph in terms of the intervals of the domain over which it either goes up or down, increases or decreases. Now the few graphs that we looked at last class, we put arrows on the end of those graphs. And that's because there was no given domain that I wanted you to graph the function over. Some functions need to be graphed over an interval. And the interval might be given like this. And by the way, when I ask you to graph a function over an interval, that interval will always be the domain, meaning it's the range of x values I want you to look at. So this domain basically says I want to see this graph between where x equals -3 and x equals +2. So when you're given a specific domain, you only graph the x values within that interval, and so there will not be arrows. Because you're given a specific interval, you will not put arrows because it doesn't keep going on and on and on indefinitely. So let's take a look at an example. We're going to sketch the graph of f of x equals 3 minus 4x. It's a linear equation because it is in mx plus b form. You guys remember. So I know this graph will look like a straight line. Because it's of the form y equals mx plus b. You got an m, the number in front of the x, is -4, which is the same as -4/1. And you have a b number of 3. Now, I know you can go to that graph, plot the b at +3 on the y-axis, and then count up 4/1, up 4/1. But look up here first and tell me, or think about, if you're given a specific domain to plot this over. I don't see it. I don't see anything like this written here. So this is the one where, yeah, you can just go up to b equals 3, put your dot, and go up 1, 2, 3, 4 over 1. And down 1, 2, 3, 4 over 1. Notice I'm making sure that my points go in a downward direction. And I'm going to connect those and put arrows on the end. This is the equation f of x equals 3 minus 4x. There was no specific domain. Go ahead, put your arrows on the end. Now the things I want you to think about when I ask you to analyze a function, first are the domain. Well, remember, the domain is the x-axis. You've got an arrow on this side. You've got an arrow on this side. So that means that the domain goes from -infinity to +infinity. The range is the y-axis. Also, the arrows are on either side, so the range is also from -infinity to +infinity. Now I'm going to determine the intervals of x for which the function is either increasing, decreasing, or constant. Keep in mind that when I ask you for an interval over which a graph is behaving a certain way, I'm talking about the interval of the domain. Well, if you look at this line, isn't it always going to go downhill? It has a negative slope. And that -4 slope is going to remain constant. So the interval for which it's increasing, I would just write never. It's never increasing. It's decreasing from -infinity to +infinity. And it's constant never. Keep in mind that constant means it would be horizontal. It doesn't have any horizontal sections to it. Now let's see what the difference is when I give you a specific domain for which to graph a function over. For this example, I'm asking you to graph g of x equals 1/2 x plus 4 over a specific domain. The second you see a specific domain, I don't care what the equation looks like, if it's linear, quadratic, or any of the other functions we're going to look at this year, I want you to immediately draw an XY table and put the domain into your table. I want you to look at where the x values go from -2, including -2, all the way up to 4. So that's what you're going to put on the x side. -2, -1, 0, 1, 2, 3, 4. And you're not going to go beyond those x values. Those are the only points we want to see on the graph. Now, of course, we know this is going to look like a straight line because it's in the form y equals mx plus b. It has a slope of +1/2, so we know the line's going to go uphill. It has a y-intercept of 4. Now you certainly could go plot your y-intercept at +4 and count up 1 over 2, up 1 over 2, but typically when we're over a specific domain, I tell kids to just go put this in the y equals of your calculator and pull up the table on your calculator. Next class we'll get into doing that because we're going to look at functions that are not linear. But for this one, we can just figure it out. What's the y going to be? Well, what's 1/2 times -2 plus 4? We're just using our equation to find the y value. 1/2 of -2 is -1 plus 4 is 3. Now, since you know it's linear, you know that it goes up by 1/2 each time. So the next value would be 3.5. The next value would be 4. Oh, look at that. That's the y-intercept. Sure enough, isn't that our y-intercept? The next value would be 4.5. The next value would be 5. When x is 3, y would be 5.5. And when x is 4, y would be 6. So now we can plot those points. -2, 3 would be to the left 2 and up 3. -1, 3.5 would be to the left 1, up 1, 2, 3.5. Sorry about my stylus doesn't do dots very well. 0, 4 would be right here. You're just going up by 1/2 each time. Now we don't want to go past x equals 4. 1, 2, 3, 4. That's why I'm stopping right here. So you're just going to connect those dots and you're not going to put arrows on the end. And since there is a line underneath this inequality symbol and a line underneath that one, we're going to do closed circles at the end of this function. If there happened to be no line, let's say under this piece here, we would have put an open circle above x equals -2. So now the range and the domain change a little bit. The domain is the x values. If you look at the x side, we start at -2, we end at 4. So the domain is square bracket, -2 comma 4, square bracket. The range for this function over this domain starts at +3 and ends at 6. So your range would be square bracket 3 comma 6. Now the reason we can use interval notation here is because we have an equation and all these points are connected. So all the x values in between also have a y value attached to them. Determine the intervals for which x is increasing, decreasing, or constant. Well, let's go take a look. It's always increasing. So the interval for which it's increasing, remember, when I ask you for an interval over which a graph is behaving a certain way, I'm talking about the interval of the x's. So the interval for which it's increasing, which it always is, would be the same as the domain. It increases from -2, 4. It never decreases, and it is never constant, because remember, constant means it would look like a horizontal line. So we'll practice this a little more next class. If you have a graphing calculator at home, please bring it to our next class. Otherwise, one will be provided for you, and we'll dive into some equations that aren't linear next time, and we'll figure out how to use the calculator to help us come up with those tables and in turn graph those equations. And have a great night.